Before we continue, let's have a quick look at how Metamask works behind the scenes, because maybe that's not exactly clear how that magic trickery here actually works, that Metamask gets access to the blockchain. Does it have its own node, or how does it work? And so what I kind of want to answer in these few slides is, what's that magic box? How does that even work? So there is no magic trickery. There is a service provider called Infura, or at least it was. I'm not sure if they're still with Infura, but I think they're still with Infura. And Infura is running its own blockchain nodes internally in the data centers, and they have convenient access to those blockchain nodes. And the blockchain nodes itself, they are storing, or they are syncing the data with the blockchain and always keeping it up to date. And then you have an RPC method, or a REST interface, or a WebSockets interface to actually connect to those blockchain nodes, but it's going via Infura. And there's a couple of others that are now popping up every now and then. Alchemy is one, and there are more of them. So running a blockchain node, keeping it in sync is really a pain sometimes, especially if you want to have a high degree of uptime, load balanced for many users. So that one is totally abstracted away. All that Metamask does, it's conveniently connecting to Infura data centers. I think they're running on AWS, but don't nail me down on that. And then connecting to blockchain nodes there. And Infura is doing the heavy lifting. The next thing we did is we had a look at the faucet. It looked a little bit different than this faucet, but from our browser, through some magic trick, we had influenced the blockchain by clicking a button, logging into Twitter in the videos, but maybe you use this faucet. They all look a little bit different. But the point is, somehow, somewhere, this one ETH on Coven, or this Robston ETH, or I don't know what kind of faucet you used, at the end went into our Metamask wallet. How does that work? Is this some kind of magic? No, it's also no magic. There's a browser, there's a normal backend in the background, and then this backend is connecting to blockchain nodes. It can be Infura, it doesn't have to be Infura. They might even run their own blockchain nodes. Who knows? The point is, those blockchain nodes are syncing in with the exact same blockchain, and they are having the exact same underlying ground truth of data. So when you send the transaction over here, then it's also getting over here. And at the end, you have basically a public database that is openly available to everyone, and just the different implementations, or just the different participants, be it the backend, or be it just a browser, or be it Metamask, are getting access to the same kind of data. Then we had a look at Etherscan. We were looking at our transactions, both on Robston and Coven, and we saw on Coven there's the ETH coming in, but on Robston not. How does that work? Well, exactly the same. Blockchain node behind, somewhere writing in the database in Etherscan. So Etherscan is not directly, when you are on the website of Etherscan, you're actually looking into the Etherscan centralized database, but the database gets data from the blockchain, and they are running their own blockchain node. So it's the same thing. Blockchain node gets access to the underlying data. And there's tons of other nodes out there. This can be, you might have seen it, Go Ethereum, or maybe Parity was it before. Now it's Ethereum, I think. And there's new ones popping up. So nodes are pieces of software that are implementing the Ethereum protocol. And this Ethereum protocol allows other nodes to sync on the data, on the underlying blockchain data, which is block by block, added in small increments to the overall data that is available, but they are chained together with a hash of the previous block into the new block. So you cannot change information anymore. And that's exactly what I want to deep dive into the next lecture, because this is one of the major features of blockchain over a normal database. So what are the key takeaways here? You need a blockchain node to interact with the blockchain, or you use something like Infura, but they are running the blockchain node for you then. So the blockchain node is like the access to the blockchain data. The blockchain is the single source of truth. There is nothing like a sharding at the moment. It might come later with Ethereum 2.0, or maybe we are already there. But right now, there's just a single source of truth, which is the blockchain. And if you are connected to the main network, then you are connected to the Ethereum main blockchain. That's it. There's nothing else. That's it. There we are. And if you want to bring data over to Polygon, that's a different blockchain. But it's going to be then the Polygon blockchain is the single source of truth for the wallet that you're connected with. There are infrastructure providers like Infura or Alchemy or others, and they abstracted running a blockchain away from you, which is very often very convenient. If you're running any kind of mainnet or any kind of networks in production, I can very much recommend you looking into infrastructure providers, unless you want to become one. And it might be worth to invest extra time into trying to get Geth to run stable. Other than that, it's a real hassle, and it's good that they're there. All right, that's it that I wanted to talk about, and I will see you in the next lecture.